Evening. So this is the video based on the CSIR NET exam for the chemical science paper. I am an IITian and I have qualified my GRF in the first attempt in the December 2017, and this was my second attempt. And so this video I am making to just give the first impression of the paper, like how was the paper and what may be the cutoff, and also I'll discuss some questions of part B and part C, and only from physical and inorganic part, because I didn't attempt any question from organic part. Um, so the paper was not that much difficult and that much easy. It's because I saw the paper of June 2018 and also the December 2017 that I gave. So based on that, the cutoff should be in between 105 to 110. Okay, because as compared to the previous exam, that was the June 2018, this paper was not the physical chemistry part was not that much tough. Okay, and also the inorganic part little bit they increase the difficulty level, but the physical part was not that much tough in this paper. So I have the booklet C, booklet code C I have. So I'll discuss the question based on this booklet. So I hope that you guys, as I said that today I will discuss some question from part B and part C of this chemical science paper, December 2018. So this is a question number 22 from booklet C, and the answer should be one 5-membered ring and three 6-membered ring. The reason, because the in vitamin B12, the ring, the porphyrin, that is not the porphyrin, that is a choline ring. In that, one bridge atom was missing, so it will lead to the formation of one 5-membered chelate ring and three 6-membered chelate ring. So the option 1 is correct. Now for magnesium complex of ED2 minus, the number of N donor and oxygen donor centers are. So if you see the structure of this complex, so it will be like this is, and then so this will be the structure. This is, so this will be the structure. In this case, you can see there are 1, 2 and 3 and 4. There are 4 oxygen donor atom and 2 nitrogen donor atom. So the 2 and 4 is the correct option. Then the correct set of electronic configurations for methionine octadiol contain John Taylor distortion. So the strong John Taylor distortion will only occur when there is a degeneracy in the EG state. So in the degeneracy in the EG state is, in this case there is a degeneracy in EG state, and in this case and in this case, in all the three cases there is a degeneracy in the EG state, that is dx square y square and dz square orbital. So that's why this will lead to the John Taylor distortion. Now in this case, this is the correct order of the acceptor ability of phosphorus ligand. Okay, so the correct order will be option number 2. So then, so this is the question from the 31P1H NMR spectrum, and I didn't attempt this question, but very soon I will generate the answer key, and please subscribe my page so that you will get the notification as soon as possible. I'll just I hope that till tomorrow I will just upload the answer key. So this is the question number 27. In this case, the answer should be 4 and I2, because all others are paramagnetic, having the unpaired electron. And the correct statement for BH3CO, so you know very well that sp2 hybrid orbital of B except the lone pair electron, this is false, because that is a pure pz orbital, and only this option is correct, that its nu CO value is more than that of free CO. So only B only option will be correct. In this case there is a question. So in this case you can see that, so I should mark this as circle. So in this case, as you can see that this is the match column 1 and column 2. So in this case, laser source belong to the spectropolarimetry, gelatin belongs to the polarography, thermometric reaction belong to the heat of reaction. So you can see the option number A fourth, B third, C second. A fourth, B third, C second. So the option number 1 is the correct option. Now consider compound PF5, SBF5, PS3 and SBS3. The strongest acid and the strongest base among the following is. So this is the option. The correct option is this one. The SBF5 and PS3. So SBF5 will be the stronger acid and PS3 will be the strongest base among these. Then among SiCl4, POCl3, NF3 trans. So you should just draw the structure and then you will get that SiCl4 and trans SnCl4 pyridine 2 will lead to the zero dipole moment. Then the standard reduction. So the option number 3 is correct in this case. Now in this case, standard reduction potential in acid medium for F2Cl2 NaZn. So the order we have to tell. So the standard reduction potential, if you will see, then because after hydrogen, means going down in the electrochemical series after hydrogen, the value become positive. So if you arrange it in the increasing, means in the decreasing order, it means most negative value for the sodium, then for zinc, then for chlorine, and then for fluorine. So this will be the value, order of value. Now in this case, the character of the LUMO of Cn minus and O2, that will be the pi g and sigma u. If you guys have any doubt or any problem in these solution or answers, so then you can give me a message on my video and then I will give you the proper solution, because it is very difficult to discuss all the problems, okay, and all the solutions. In this case, this is the mechanism of acid catalyzed hydrolysis of benzonitrile involves. This is the option number 2 is correct. In this case, they gave this is an intermediate, not a transition state. This is an intermediate, so intermediate will belong to the 2. Okay, so because 1 and 3 are the transition state. Okay, so this is the organic part, as I told that but this question I attempt, and most probably the option should be the third. So there is a reason behind this, and because you all know that this B will be having the highest stretching frequency, the carbonate stretching frequency. The reason is because in this case the O is in the cross conjugation. Due to the cross conjugation, it will have the positive charge that will lead to the more electron withdrawing power, and that will lead to the more stretching frequency of the CO. But in the two options there is the B. So you maybe the student can be confused in these two options, but according to me, the C should have the more stretching frequency, carbonate stretching frequency as compared to this, because in this case the resonance is more preferable as compared to in this case. So the order of relative rate of cyclization of, because I hope that all you know the order of the stability of this lactone ring. So lactone ring will be stable in the 5 member is the most stable, then 6 member, and then 4 member. So this is the BC. Option number 3 is correct. Okay, then oxidation of this. So according to me, because organic part, as I told you that I didn't attempt, but according to me, because in this case both CHO as well as OH group should get oxidized in the carboxylic acid, and the product should be the meso product. So meso product, so it should be optically inactive as it is a meso product, according to me. This question I didn't attempt even. In this case, only one option you can see easily, that C should have because rotation will become very difficult, because 2 tertiary butyl group will repel, means steric hindrance will be there. So that's why C should have the least reactivity towards the desired reaction. So only the option number 1 is there. This is option number 1. In this case, you can just pass the plane. There is a plane of symmetry, there is a plane of symmetry, there is a plane of symmetry, but there is no plane of symmetry, so it is a chiral molecule. So option number 4 is correct in this case. So this is the again organic, but I attempt this question. In this case, if you take the tertiary butoxide, so in this case you will get the terminal alkene, and in this case you can get both, because there is not that much steric hindrance, so you can get both. But in this case, this is a particular reaction to get the less substituted alkene, so A and C should be the correct option. So now this question I didn't attempt even in this question, because this group is a leaving group. Okay, this group is leaving group, so you have to check the stability of this carbon. In this case there is a 9 alpha hydrogen. In this case there are 6 alpha hydrogen. In this case there are 3 alpha hydrogen, and in this case there are 0 alpha hydrogen. So the option number 1 should be the correct option. Then this is the physical, then that part I love so much. So this is the 50th question. Answer is 4th. Solution, if you want that I can give you. In paper I did all the solution. This, according to me, the answer should be the first one. I'm not sure, but answer should be the first one. This is all you know. The fructose is the ketohexose. In this case the answer is this one. I solved all this question. You can see that I solved this question during the paper even. And in this case sodium atom has closest state I already calculated, and the option number this, because it is the emission from the sodium, so it is a 2p3/2, because there are two states. This is 2p1/2 ground state and 2p3/2 excited state. This is 2s1/2. So the transition can take place from here to here, which will lead to the emission. And this one, this is the higher energy line, this is a lower energy line. So higher energy line is 2p3/2, 2s1/2. The answer is 2 in this case. This is the question. Point group of N2 molecule, because N2 molecule has this structure, and negative and positive. So in this case there is a d infinity axis along this molecule, but not perpendicular C2 axis. There is no center, so that's why C infinity way. Now this question, this is the thermodynamics, very easy question. I think that all of you easily did this question, the correct relation. And this salt bridge is allows to not mixing of the solution, because some people maybe take this option, because salt bridge never mix. Because what is the need of salt bridge required to separate the two solution. Okay, so this is the correct option, that half cell without mixing the solution. In this case the correct, because the problem in this case, the problem is that they give this, where this notation, the given rotation is wrong, because notation should be Ag plus Ag, not Ag plus, because it is a reduction potential. Actually after hydrogen all elements have their reduction, means after hydrogen in the electrochemical, if you will go, then you will get a positive reduction potential. It means they are more prone to reduce as compared to hydrogen. So in H plus solution they will not replace the H plus ion, they will not means generate the H2 from H plus. So the correct option in this case is, according to me, the 70 kilojoule per mole. Now in this case this question, because this is a physical part, but still in this question I didn't attempt this question, but I think the option should be this, but I am not sure about this question. I'm not sure about this, but in this case it is clearly face centered cubic, because face centered cubic either all should be even or all should be odd, but the 001 there is a even odd, so that's why it will not observe. So explanation, if you guys want explanation from me, then hope that you like this video, and I hope that it will help you in some manner. And very soon I will come back with the part C, because already I just did the part C in the examination. Most of the physical chemistry part and inorganic part I attempt the 25 question in this part C, and so most of them maybe I think that they should be correct. And I will come back very soon with a complete answer key of this whole paper. And please be with us on our channel, that's the Chemistry Makers. So thank you for watching the video.